Good morning friends. In the last lecture, we have started with this topic, rotational dynamics. And in the introduction part, already we have seen motion and the different types of motion. So from that lecture, you will get the idea about the name of the topic, that is a rotational, the one type of motion in which the axis of rotation is important. And dynamics, it is the branch of the mechanics which deals with the study of motion with their causes. So in this topic, now we are going to discuss about these points related to the circular motion. Now the first point which is given here, that is related to the characteristics of circular motion. Now we know the diagrammatic representation for the circular motion. Suppose if we consider the particle is moving along the circumference of circle. This is shown as the anti-clockwise sense of rotation. This is considered the center of circle, which is O. Now if you observe here this circular motion, suppose if we consider the position of the particle is at P. In circular motion, we consider a single particle. If we join this OP, it is called as radius vector or the position vector. Now as the anti-clockwise direction is shown, then this particle will move along this direction, along the circumference of circle. Because we know the definition of the circular motion, the motion in which the particle is moving along the circumference of circle. Okay. Now when we consider about this is a circular motion, particle is taken at this point P. If we show the direction of the velocity, then you will find this is the direction of the velocity when the particle is at P. Now this velocity is called as linear velocity or tangential velocity. Initial velocity or tangential velocity. Tangential velocity. Okay. Now when this particle suppose reaches to this point, so the direction of this velocity also changes. As the time passes, the particle will move in this direction. Suppose if we consider this is the position of the particle, then this is the direction of the velocity. Similarly, we can show here this is the direction of the velocity. So you will get idea here. As the particle changes its position, the direction of the velocity also goes on changing. Means there is a change in the velocity, and we know whenever there is a change in the velocity, acceleration is produced. So the characteristics, that is the first characteristics is given here, that is accelerated motion. Accelerated motion. So you can observe in case of circular motion, the direction of the velocity goes on changing. So acceleration is produced there. So this is the first characteristics of circular motion, that is the circular motion is accelerated motion. And the second characteristics is given. This is the periodic motion. Now what is the meaning of this word periodic? You have heard about the word period. What is meant by the period? The time required. So this is a concept related to the time. This is the concept related to the time. Time required to complete one revolution. Here particle is moving along the circumference of circle. So suppose particle will start from P, it will move along the circumference of circle and again it will come back at point P. So the time required to complete this one revolution, it is called as the period. It is called as the period, or it is called as the periodic time. And this period or the periodic time, it is represented with capital T. So the circular motion, it has this periodic motion. This is the second characteristics. Means the particle is moving along the same path again and again. So the trajectory word is used in the textbook. That is, the trajectory means that is a route along which the particle is moving. So in case of circular motion, the particle is moving along the same path. It repeats the same path again and again in equal interval of time. Then and then only we can say this motion is the periodic motion. So you will find in case of the circular motion, these are the important characteristics of the circular motion. So for VSA, the 1 mark question can be asked from this point, that is characteristics of the circular motion. Now when we consider about this circular motion, then now we are interested to discuss about the information related to the kinematics and the dynamics of circular motion. Now you will find here, we want to find out the kinematics of circular motion. Kinematics of circular motion. Now what is meant by the kinematics? Again we have seen kinematics is the branch of mechanics, and it deals with the study of the motion of an object without considering their causes. Without considering their causes. Already we have seen this word in case of the kinematical equations. In the last lecture, we have seen the kinematical equations for linear as well as circular motion. If you observe these kinematical equations, you will find there is no term related to the force. So, in case of the discussion of the kinematics, we are thinking only for the motion of the object without considering their causes. Okay. Now, when we consider about this circular motion, now in case of the circular motion, we know there are the three terminology which is considered, that is angular displacement. Angular displacement. This angular displacement is denoted with theta. Now in this diagram we can represent the angular velocity here so that you will get idea about this. So suppose if we consider O is the center of the circle, P is the position of the particle, V is the tangential velocity. So in the time t, the particle will move through a certain distance, suppose the particle is at here, so we can draw again the radius vector. Now we know here the radius of the semicircle is the same. So this angle, this is a plane angle, it is denoted as theta. So in case of the circular motion, we are going to use the angular displacement terminology, that is an angle traced by the radius of vector in a given interval of time. It is called as the angular displacement. We know again the SI unit of this angular displacement. It is given as a radian, or in short, it is written as rad. Again, if I want to write the dimension, then we know dimension is written in terms of LMT, but their powers are 0. So this is the first terminology you should know in case of the angular displacement. The second is shown as the angular velocity. Now angular velocity is denoted with omega. How we can find out this angular velocity? We know the simple formula. This angular velocity is depends on angular displacement. So you will get the formula for this angular velocity. It is rate of change of angular displacement. So this is the basic formula from which you will get the definition. Similarly, we can write the SI unit, which is given here as radian per second. Radian per second, because it is the ratio of angular displacement divided by time. Similarly, we can mention dimension of this terminology, that is LMT, t raised to minus 1, and power of L and M, it is 0. Thirdly, we can find out angular acceleration. Again, we know angular acceleration is denoted with the alpha. This angular acceleration is depends upon angular velocity. So you will get the formula alpha is equal to d omega upon dt. So the rate of change of angular velocity with respect to time, it is called as the angular acceleration. Similarly, we can find out SI unit for this. It is radian per second square. So what will be the dimension? You will find here the dimension will be t raised to minus 2. So this is the very simple terminology which is used in case of the circular motion. You will get like this. Now these are notations, that is theta, omega and alpha. All these are the vectors. All these are the vectors. So we know in case of the vectors, that is they require magnitude as well as direction. They require magnitude as well as direction. So the direction of all these three, it is given with the help of right hand. Also we have seen this right hand. Right hand. So if we draw the diagrammatic representation related to this direction, then you will find the motion. It is represented like this with the help of this vertical circle. Vertical circle. So we can consider, suppose there are the such two possibilities. That is, one, the particle is moving along anti-clockwise direction and the particle is moving along clockwise direction. So let it be considered this direction is taken as anti-clockwise and this direction is taken as the clockwise. So the direction of this theta, suppose if we consider the particle is here, so this is the direction of the tangential velocity. Okay, this is the direction of the position vector, that is r. Okay, and now we want to observe the theta. So as the particle is moving here, we can show this angle is theta. So it gives the plane angle. But how we can find out this direction? According to right hand rule, you will find the direction is in the upward, that is theta. So the angular displacement you will find it is in this direction. Okay. Similarly, in case of the clockwise direction, you can develop this diagram so that you will get idea about this. So suppose this is the position of the particle. Okay, and now the particle is moving in this direction. So the tangential velocity will become in this direction. This is the radius vector. It is r. This is v, that is the linear velocity. So now if you observe this, the particle is moving in the clockwise direction. So the direction of this theta, it will be in the downward direction. It will be in the downward direction. Now, if we know the direction of theta, omega is depending upon theta. So you will find this angular velocity is also in the direction of the angular displacement. Here also you will find it is in the direction of the angular velocity. Okay. Thirdly, how we can find out the direction of this angular acceleration? Angular acceleration is depending upon the angular velocity, but this angular acceleration, it gives the direction such a way that if omega goes on increasing, the omega increase होत असेल, then this direction of alpha, it is in the direction of omega. So in case of the fan, we have explained this already example. Switch on, angular velocity goes on increasing. In that case, the direction of this angular acceleration, it is along this same direction. Okay. Otherwise, if omega goes on decreasing, the direction of the alpha, it will be in the downward direction. Means in this situation, if this is related to alpha, when we consider omega increases, otherwise you will find the direction of the alpha, it is in the downward direction if omega decreases. So it is very important one, omega increases and omega decreases. फॅन चालू केल्यानंतर जसं स्पीड वाढत जातं तसा फॅन आपण जर बंद केला तर त्याची अँग्युलर वेलोसिटी कमी कमी होत जाते. या सिच्युएशन मध्ये हा अल्फा अँग्युलर ॲक्सेलरेशन इट इज ऑपोजिट इन डायरेक्शन टू द अँग्युलर वेलोसिटी. सो यू विल गेट आयडिया अबाउट दिस. Now if you observe in the diagram, then you will find related with this, all these vectors, they are along the same axis, or all the vectors are along the axis. So all these vectors, they are called as the axial vectors. Now when we consider about this explanation, it is analogous to linear, which is already we have seen. So also we can conclude that in the kinematical equations of circular motion, you cannot observe the terminology like force. And these kinematical equations also we have seen here. This is kinematical equation for circular motion. Now when we consider about this kinematical equation, so here you will find all are moving along the same direction, which is called as the axial vector. But when this angular acceleration is a constant, then and then only we can derive these kinematical equations. Analogy लक्षात ठेवून you can compare these kinematical equations. जसे की लिनियर मोशन साठी आपण जे kinematical equations घेतो त्या पद्धतीने कायनेटिकल इक्वेशंस यू कॅन रिप्रेझेंट हिअर. सो these are the three kinematical equations. जसं लिनियर मोशन मध्ये आपण v is equal to u plus at हे इक्वेशन, इथं आपण ओमेगा is equal to omega 0 plus alpha t. So these are the analogous terminology. Similarly, the second equation is s is equal to ut plus half at square. So here s is equal to ut plus half at square. These are the analogous. And the third equation is v square is equal to u square plus 2 times of as. So you will find these are the kinematical equations which can be obtained by considering the analogous terminology.